All right, so let's move on to the next presentation named Toward Empathic Conversational Recommender System by Xiaoyu. I hope I could pronounce your name well.
Hi everyone, I'm Xiaoyu Zhang, a master student from Shandong University. Today, I'd like to share our work towards empathetic conversational recommender systems. Firstly, I will introduce the background of our work. The conversational recommender systems, which we refer to as CRS, is proposed to elicit user preference through multi-turn dialogues within two main tasks, the item recommendation and the response generation. Specifically, for item recommendation, CRS predicts items to user from the candidate side and based on the dialogue history to accomplish the high recommendation accuracy. And then in the response generation subtask, CRS generates appropriate response to user in the natural language to ensure their subjective satisfaction. However, existing CRS still do not fully align with user needs. They are trained on the given data set, but the perception that all the standard items and the response in the data set are optimal lead to a tendency of CRS to replicate the logic of recommenders instead of addressing user needs. This misalignment hinders the development of CRS. Specifically, for item recommendation, existing CRS often assume that all the items suggested by the user in the dataset meet user expectation, and all the entities mentioned in the dialogue reflect user preferences. However, as shown in this figure, we can find that the conventional CRS might infer that the user lacks the Shakespeare and made summer night dream, while overlooking the user has already expressed negative emotion towards them during the dialogue. Thus, such system might model user preferences incorrectly. And in the response generation, existing CRS are trained towards the standard response in the dataset, but in this figure, we can find that the response of existing CRS tend to be uninteresting and dull, which might diminish user satisfaction when interacting with such systems. So we want to explore the origins of such misalignments. So we analyzed the widely applied benchmark dataset REDEAL, and we found the following reasons. For the item recommendation, we can find that among all the recommended items, the items that is selected by users account for 4.9%, and the items that are not explicitly stated by users account for 14%. Needless to say, entities that are mentioned during the dialogue but not reflect user preferences. And for the response generation, we can find that the standard response tend to be short and lack narrativeness, often resulting in inconsistent and little engagement. So, how can we deal with these misalignments? We found two inspiring research that support our work in this paper. From the first research published in 2015, we found that people tend to emotions are crucial in the human decision-making process. And from another research published in 2021, we found that people tend to favor the agents that simulate human beings by exhibiting emotions. So, inspired by these two research, we relook at the CRS and propose a new paradigm. Specifically, we introduce everything within a CRS to bridge the gap between the system outputs and user needs. Here, we define everything as the system capability to capture and express emotions. For the item recommendation, we believe capturing user emotions expressed in the natural language during the dialogue is prominent for achieving accurate user preference modeling. And for the response generation, we believe adopting emotion-rich expression in the response can enliven user experience and improve user satisfaction. To free our approach from the influence of the low-quality datasets, in this paper, we firstly enlarge an empathetic CRS dataset. Specifically, to capture user emotions, we extract user emotion from their utterance in the dialogue history. Here, we mainly adopt the large language model to discern the nuanced user emotions from their utterance. And to express emotions, we construct emotional response. Here, we collect top-rated emotional movie reviews as an informative external resource to fine-tune the model to express emotions. Having resolved the dataset issue, to instantiate our proposed paradigm, we propose the Empathetic Conversational Recommender Framework, which we refer to as ECR for short in this paper. Corresponding to our motivations, ECR comprises two key modules: the emotion-aware item recommendation and the emotion-aligned response generation. Firstly, in our emotion-aware item recommendation module, since entities are essential in reflecting user preferences, so we aim to model the effect of user emotions on the entities. So in this module, we first extract entities from the dialogue history and the training datasets. Then, we fuse the user emotions with the entities to get the emotion-aware entity representation. To comprehensively model user preference based on their emotions, we construct emotion-aware recommendation prompts based on the emotion-aware entity representation. And in the second module, in the emotion-aligned response generation module, to satisfy user information needs while mitigating hallucination, we construct emotion-aligned generation prompts based on the knowledge retrieved and extracted from the knowledge graph and the movie reviews. And to align our generator with the persuasive dialogue style and human emotions, we fine-tune a pre-trained language model as the emotional-aligned response generation, as the emotion-aligned generator, using the constructed emotional reviews in the training stage. And in the inference stage, we use generator to decode the emotion-aligned response. Here, we adopt both the Dialog GPT and the Llama 2 chats as our backbone model as the generator. Considering the traditional metrics adopted by existing CRS are highly dependent on the original dataset. So in this paper, we also propose the new emotion-enhanced evaluation matrix, which considers the user satisfaction in the real-world CRS scenarios. It comprises both the objective and subjective metrics to evaluate the item recommendation and the response generation, respectively. For the item recommendation, besides the traditional metric recall, we also propose new metric recall true, which only considers the item that get positive user feedback. And we also incorporate the AUC metric, which emphasizes the rank between the items that get positive or negative user feedback. And for the response generation, we move beyond the traditional objective matrix, opting instead to propose 5 subjective metrics, which is emotional intensity, emotional persuasiveness, logic persuasiveness, informativeness, and lifelikeness. Here, we employ the large language model-based scholar, which is GPT-4 Turbo in this work, to automatically assign scores to the response based on the specific prompt. And for the baselines, for the item recommendation, we mainly compare ECR with several CRS approaches. And for the response generation, we mainly compare ECR with the powerful open source large language models. Here is the evaluation results. For the item recommendation, we can find that ECR significantly outperforms all the baselines, especially in recall true at 10 and recall true at 50. Moreover, ECR also demonstrates a significant lead in the AUC metric. These findings confirm the importance of capturing user emotions in enhancing CRS ability to accurately estimate user preferences. And for the response generation, from this table, we can find that large language models in the zero-shot setting significantly outperforms UniCRS, which is fine-tuned on the Intel dataset. This finding indicates the superior quality of the dataset standard response. Moreover, we find that our Llama 2 chest-based ECR surpasses all the baselines, and our Dialog GPT-based ECR achieves a comparable performance with GPT 3.5 Turbo, even though it has significantly fewer parameters. This finding confirms that ECR is more human-like by expressing emotions, thereby improving user satisfaction. So in conclusion, in this work, we look at CRS and propose a new paradigm. Specifically, we introduce empathy within a CRS to bridge the gap between the system output and user needs. And we also construct empathetic CRS datasets and propose new evaluation metrics, which significantly facilitates the future research. Finally, our extensive experimental results verify the effectiveness of our instantiate ECR in improving recommendation accuracy and user satisfaction. Moving forward, we aim to adapt ECR to more challenging settings for recommending items concurrently. So, thanks for listening. We have released our code and data on GitHub. You're welcome to download the code. In the end, I'm looking for a PhD position. If you are interested in our work, you can scan this code to get my CV.
All right, thank you very much. Okay, so we have time. I'm gonna ask the only question which we were given here. The question I ask: how do you deal with LLM instability when generating scores for subjective metrics?
Considering the instability of the large language models, we also invite 3 human annotators to assign scores on our 5 subjective metrics. Due to the time limitation, we didn't show our results in this PowerPoint, but you can refer to our paper to find more details.
Okay, thank you very much. Let's see if there are questions from audience. Okay, we have time. I will ask 2 quick questions. One is again about the evaluation. So it seems there are 2 types of output from the system. One is like the items recommended, and the other one is like the response. So I was curious if these metrics that you show look at the alignment between the 2. Like, is there like any of these metrics look at the alignment between the response generated and the actual items? And the second question is also in this line, like, do you think, because emotions, when we talk about that, like in different contexts, in different domains, could mean differently, and LLMs could have also different abilities. So do you think, like, if the results of this system are applied to another domain, which is less emotion, let's say, emotional things might differ. I don't know, some insights maybe you have, because it seems you're using a classic data set for conversation, so yeah.
Yeah, for the first question, do you mean how to align the generated items and our response?
Yes, exactly.
Due to the time limitation, I didn't introduce our emotion line generation module in detail, but we do apply a retrieval augmented prompt, which means we retrieve the knowledge using the predict items in our first module, which so we can make sure that our generated response will contain many informations about our recommended items, which will make it more convincing and engaging. And I'm sorry, the second question I didn't
The second
get.
question was general about the generalizability of this work to other domains, if you have any insights. Like, for example, from a movie domain, when we go to another domain where users, let's say, look at for items more emotionally or less emotionally, do you think there could be differences?
Of course, I think since our work was concentrated on moving recommendation, and I have shown to inspiring research that people tend to favor the agents that simulate human beings. So I think people will definitely prefer the agents that will have the emotions in other domains, not limited to the movie recommendation.
Okay, thank you very much. Please give a round of applause for